Okay, looks like it's working. So I'll just start with the intro and then say hi to you. Welcome to Slow and Steady, the podcast where you get to follow along as we build products in public. Each week, we'll give you an honest peek into our lives as we share our struggles, our wins, and everything in between. I'm Benedict. Today is July 25th. This is episode number 185. And I'm feeling excited because I'm joined by Andrew Atkinson. Andrew is a software engineer at Fountain and very passionate, just like me, about PostgreSQL and Rails. And he's even so passionate that he's currently writing a book called High Performance Postgres with Rails. Welcome to the show, Andy.
Thank you. Glad to be here. Excited to be here.
Yeah, we've been chatting a little bit before, and like we've been following each other for a while and like chiming in on various things on the socials. And so it's nice to finally have a proper conversation with you, even if it's just via video call.
Yeah, it is. It's great, and I think it's still really cool to be able to communicate across the ocean like we're doing, and low latency, and it's hard to meet otherwise. So it's a great opportunity.
If it weren't for time zones, right? That's the one thing we're probably never going to fix.
Yeah, that is a tricky challenge especially for today's modern distributed companies and that kind of thing.
Yes, exactly. Well, we initially got the idea of recording this episode because of a post I sent out on the socials last week. And basically, there was a situation where I was working on a critical part of our application, let's put it that way, and fiddling with stuff and changing stuff in our application code and then rolling it out to production. And everything seemed fine, like tests were passing, all of it. But then I got one error from on our exception notification system, and that said something like, couldn't write entry to the database because there's already a record in there and stuff like that. And that was once again a time where I appreciated database constraints and appreciated the fact that they prevent me from screwing up. Traditionally, at least, it feels that way. I feel like as Rails developers or like the Rails community, at least in the early days, didn't really appreciate databases as much as it maybe should, or maybe as it does today. So you suggested that we just record an episode about this, like about database constraints and how they can save your bacon in production.
Yeah, I thought that tweet was cool because it spoke to a real world experience I think a lot of developers have. And as a developer that has, learned more and more about the capabilities of the database, I think that what I am passionate about is trying to help others learn about and put to use some of these capabilities. And I agree. Having done Ruby on Rails for a really, really long time, more than a decade, across a lot of different companies and different types of apps, I think that there are different ways Ruby on Rails didn't actually directly support database level constraints. I had looked this up recently. I think it was in version 4.2 is where it was added, which was, I think, 2014. And Ruby on Rails, as we know, came out in the mid 2000s, the aughts. And so there was quite a lot of number of years there where it wasn't directly supported. And, I think you could speculate why. Like, there might be, there was a lot of emphasis on database portability. Don't use too much of the capabilities of one database, relational database, because you might move to another one, and that kind of thing.
Yeah.
And there could be other reasons, but yeah, I'd love to, we could get into some of the specifics, but for example, even just making sure, your fields where you don't expect there to be null values, or where you have a really good idea of what uniqueness looks like on a table, being able to add those things to your table helps improve your data model and helps reduce the chances for bugs.
Yeah, absolutely. Yeah, it's funny, like that, like database agnostic Rails setup. Have you ever encountered in your career like a case where someone actually migrated databases, other than like
I
in the first 2 weeks of development, something like?
Right, exactly. Yeah, maybe right away, but I mean, I think that no, I know that one company I joined, they had moved from MySQL to Postgres before I had joined, but again, it was kind of like I don't even know. I don't think it was for technology reasons. I think it was well, I guess that was before I joined, so I don't know too many of the details, but in the time that I've ever worked at a company, which is some number of years typically, like, the relational database when I started is the same relational database that was being used when I left. And, you know, the, as you know, I'm very enthusiastic about Postgres specifically. And so I've kind of made the choice to specialize more and learn more about it more deeply, and the ecosystem, and some of the history behind it and that kind of thing. And um, the, it's part of my reason for doing that is because it has become more and more popular with professional developers. And there is a Stack Overflow survey that adds some weight to that as well. I think there were 50,000 respondents. And I believe in the summary of that was that Postgres has recently become the more popular choice. I think used in, I'm not 100% sure now if it was solely at work or also for kind of personal projects or both. But Postgres, using the same metric, had overtaken MySQL in popularity. And so I think, and the reason I'm saying that is because I think regarding the moving databases, like, they're really, it's part of the stack of software that a business needs to run their web application or their other types of applications. And there's both a technical component and there's also a social component too. It needs to be a popular tool to help attract and retain, team members to help build and grow the platform. So if, both for my own personal interests and professional interests, if Postgres was a really dying relational database and it wasn't, having all these great things that it does have, like annual releases, constantly improving performance, improving functionality, great documentation, that sort of thing, I wouldn't be investing so heavily in it. And I think businesses might be more likely to move too, right? Like teams might be like, hey, this is not something we want to keep investing in. But in fact, the opposite is true. I think if you are, and probably the same thing for, I think on the MySQL side, there was the MySQL MariaDB fork a number of years ago, and I'm not as involved in that world, but I think that's probably fairly stabilized. So I think if you're, if your team is building on one of these kind of bigger open source relational database management systems, like, there isn't a lot of incentive to switch.
Yeah. And I also feel like that like mentality of like staying super far away from, or like not making use of the database that you're using, like fully use by like not using all its features. I feel like you're doing yourself a disservice, because databases are a great tool. And if you are afraid to fully use them and fully utilize them just because you might move to something else in the future, I think that's just not going anywhere, and you're missing out on a lot of things. So
right. And
yeah,
it should be, we haven't mentioned this yet either, but it's very important to note that Postgres is very standards based, and there is the ANSI standard for SQL. So if you write, and of course, we started talking about database constraints. Most of the common constraint types there's going to be equivalents in other relational database management systems. So if you were to ever do a migration for some reason, that would be part of your migration. You would say, okay, we have this not null constraint, this foreign key constraint. We need the same one created on the other side. And so, yeah, I think that argument is, I don't know that anyone, I don't really see people talking about that for many years now.
Yeah,
But
true.
even if someone dug it up and said, let's argue about this again, I mean, you really could make the case that it's, any sort of big migration like that is going to have a lot of complexity, and migrating your database objects, like your constraints, is going to be just one of the pieces. So
true. Yeah.
Absolutely. Okay, with that out of the way.
With that out of the way, now that we've made our opinions clear on that outdated statement, talking about database constraints, you mentioned the most obvious one is like not null or null enforcement. What's your second most popular database constraint that you use a lot?
I would say, foreign key constraints, and having a good expressing your data model. So I think you also work with Ruby on Rails. Is that correct? And
yes.
Okay.
Yes. Rails, Active Record, Postgres. We are fully aligned on the tech stack.
Okay. Yeah. So we mostly use the same tech stack. And but if you use another object relational mapper besides Active Record, you might express your relationships between your data models in the application code. And there's value in that. And of course, like it helps with, your model layer, your application code layer, navigating relationships, and that it's not just value, it's critical. But there, if you can put that information into the database by describing the parent-child or the hierarchical relationships with your tables, then not only does that enforce that relationship so that a primary key foreign key relationship stays intact, you can't delete one side or the other, it also adds a form of documentation and description to your data model that can be used by other clients as well. So if you need to do something like copy your tables, which is something I've been working on a lot lately where I work, we have these different environments and we need different row level slices of data or things like that. I can tell you more about if you're interested. But we can do that with, as long as it sort of depends on, but we invest in making sure that we have as many kind of foreign key constraints added as possible so that we know the dependencies, and we don't necessarily need the application code to know those things.
That makes a lot of sense, because then your application is usually just one of the tools that connects to the database, and reporting, business analytics, or even maintenance tools might still look at the database and the database constraints, or like the foreign keys help them figure out the data structure, because otherwise it's just tables and just not immediately obvious how stuff connects. Yeah. That's a good point.
And they're optional, and so I think it's again it kind of gets back at the opportunity that's there for developers to add, and a database administrator that maybe thinks about data a lot, or a data engineer, they might learn about this in kind of a 101 course and just take it for granted. But what I've experienced is, I think there is an educational opportunity for a lot of developers to first say, like, hey, these capabilities are here, but then actually putting them into use. And we can get into that as well, but it's not always super trivial, depending on the, unfortunately, for larger applications, either large database tables or high query volume, or both, sometimes adding the foreign key constraints is not as straightforward as just adding them and you're done. It's there's some operational challenges, like table locks that we can talk about and stuff, but they're all, there's great patterns, and I'm happy to provide some more links to some tools and that sort of thing as well, that make it achievable. It just does require a little bit more investment to add. But yeah, if you had the mindset of like, hey, we want to build out the data model and make sure that all of our table relationships are as expressive as possible, I found it to be both good as a for operational reasons, to help avoid bugs like breaking integrity, but also because of these other clients
Yeah. What I also enjoy is cascading deletes because it's so easy to forget about like the correct order of deleting stuff. And with the foreign keys and the cascading deletes, you just delete the parent row and all the children just get removed as well and stuff like that. That's super handy at times.
Yeah, definitely. Yeah. Usually it's not, with a relational data model, of course, like the more rich the application is, you're going to have, it's not going to be data in one table. It's going to be data in lots of tables that form kind of a graph of data. So if you have a parent or a root node kind of object, it's likely there's going to be lots of objects or table rows that refer to it. And they're not going to make sense likely when you delete that parent or that root node. So you might want to remove them or nullify them or something like that.
Yeah, totally. So in terms of constraints, I feel like the next one on the list is probably unique constraints. And at least for me, those are the like null constraints, foreign keys, and unique constraints are probably the ones I use the most.
Yeah.
And then for everything else, it's more like sometimes it makes sense to add an additional one, but like
they're
those
less
three
common.
are the most important ones. So
Probably
maybe we can talk about. Yeah, go ahead.
Well, I was going to say, like, we unique is of course a little more clear what it does, but there are two more constraint types, check constraints and exclusion constraints, that we could also talk about. Would you like to start with? Would you like to talk a bit about unique constraints?
Let's talk a little bit about unique constraints, and also maybe let's touch on unique indexes versus unique constraints, because that distinction isn't very clear and not necessarily obvious.
Yeah.
And it might not even be a thing in some databases.
Yeah, I only really know Postgres in this area, and I don't even, I feel about 95% confident on this, and I've written about it. So like it's a little foggy, but because I guess in practice, the way I've always added unique constraints is from adding an index. That's a common pattern I've seen in most. So in a Ruby on Rails or Active Record world, you create a migration, which is a incremental database modification or a DDL change for database people, that adds an index, and you would add a unique index that enforces that supports the unique constraint. But it is possible to add a unique constraint to a field or a combination of fields at the table level without an index.
Yeah.
I just never
it rarely happens, right?
I've never done. I've really never done that. Maybe if you knew at the outset for your table definition, as you created the table, that a particular field needed to be unique, you might. Well, my understanding is what Postgres does is when you create a unique constraint on a field or a combination of fields. I think the combination of fields, I believe you can only do when you do a create table statement, but I'm not 100% sure. You might be able to alter a table and add a unique constraint. I just haven't done that. I believe Postgres internally creates an index for that, for those lookups, right? Because the constraint also needs to be enforced at row modification time. So any insert, update, or delete, that constraint needs to be checked, and that needs to be fast.
Right.
And the way that we do that is with an index. So I believe that what I have, I don't know how much of an optimization opportunity this really represents, because I don't really see this done in practice. But I think, technically speaking, if you add a unique constraint to a field, adding an index that adds the unique constraint is a redundant index.
Yeah.
How have you handled that? Do you typically, if you, like, part of the reason I started to ask you a question, but let me say one more thing and then I'll go back to the question. Part of the reason that the index approach is used in practice is because typically, your table is not brand new or with low query volume or with small data. at least like in a scale, like in a lot of places I've worked where they're maybe mid-stage startups that are, maybe like Series A, Series B, they've got product market fit and they're in more of a scaling mode. At those points in time, adding a unique constraint that's going to lock the table while it's being propagated is going to be a challenging operation to do online, and it's not going to be something that folks are going to be excited about taking the database down for. So typically we do it with an index that we add using the concurrently keyword. And by adding the index concurrently, the unique index concurrently, it doesn't lock the table with the exclusive lock. And we can do that without taking the database down. And we can do that like whether it's a high or low activity period. And so now you have this, now you have the index and the unique constraint applied. Is that typically what you've done, or?
Yeah, like that's usually how it works. For one, because it's the way Rails does it, like supports it out of the box, right? I feel like you just do add index unique true, and that's it, right? That's one thing. And then at least in our use cases, when we enforce uniqueness, it's almost always almost like a primary key, like a composed primary key. Like, sure, we still have the ID column, which is the real primary key, but in most cases, we just have this one thing that's identified by this combination of other columns. Most of the time, it's a combination even.
Right.
So that's, usually, and because of that, we usually also want to look up on that. So the index makes sense anyways for like performance reasons. I think there's only one occasion where we actually did it the other way around and used a unique constraint without the index. And if I remember correctly, that was because we had the access list gem to manage order. And the problem with the unique index was that when you switch stuff around and like change the order, for a short period, you have like two rows with the same position, and that wouldn't work with the index. So we had to use this feature called deferred constraints, where you can basically set up the unique constraint and tell it to only check at the end of the transaction. So you were able to do a couple of inserts or updates in whatever order, potentially creating conflicts in that process, but it would only be checked at the commit where you hopefully resolved all those conflicts with additional updates. So I feel like that's the one reason why you might not want to use a unique index instead of and use a unique constraint instead.
Yep, you get that control over some of those properties of the constraint. And I guess at the beginning of the book you mentioned, at the beginning of the podcast, you mentioned that I'm writing a book. The example you just listed is actually, I think it's a common example to help illustrate how to do this, but there's an exercise in the book, as you said, High Performance Postgres for Rails. I believe it's in the chapter on where the chapter mostly emphasizes constraints. But it covers a little bit more broadly integrity and consistency and kind of what those mean and how to put them into practice. The example though with deferring the constraints to the transaction commit time, the constraint enforcement. It's funny you mentioned the acts as list, because I believe that is the exact example that I wrote about. It's pretty clear and it's open source code and you can look at it, and there's some good blog posts about it as well. So there's a lot of educational material around it. And it is a useful technique that I've used and seen it in use at companies as well. So it's not just hypothetical.
Yeah. I feel like this is the one thing everyone will run into eventually if they start, like, if you don't have any database constraints, I guess you never know. But once you realize, hey, they're useful, you start using them. And then at some point, access list feels like the OG of Rails plugins. Like,
yeah, it is.
been
It's
around
anything
forever.
acts as, yeah, yeah. Anything that
Um,
starts with acts as, or yeah, some other
yeah,
words over the
XS
years.
that's it's been around for like forever. So at some point you just use it because you want something to be ordered in a list, and then suddenly you realize, oh, now the new fancy constraint and the old plugin don't really play nice again. So everyone at some point runs into this particular one.
Yeah, yeah.
Yeah.
And foreign key constraints can be deferred as well. And I believe check constraints as well, which we haven't really talked about yet. But
yeah,
check constraints are another really interesting constraint type that actually are getting more direct support in Active Record in new versions. I believe in 7.0 or 7.1, which is not yet released. It's real in the weeds, nitty gritty, but there's some additional support for check constraint options using Active Record methods. So I think those things are possible and have always, prior to having those things, the way you would do that is you would, if you're doing an Active Record migration, is you could do execute and you could run a SQL statement inside as a string, and that's fine. But I think by having Active Record support, it helps grow the usage of those capabilities. And then also it means that capability is a standards-based capability that's going to exist in the databases that are supported, which, are MySQL, MariaDB, and I think SQLite and Postgres. And so I think it sends some kind of message like, hey, this is a supported capability. And yeah, so would you like to talk about check constraints for a bit, or?
Absolutely, because that's one of those that I haven't really used. I don't think we have a check constraint in user list at this point. So would love to hear some use cases and maybe some examples of what you use them for, if you have used them for.
They're pretty simple conceptually. It's really just any Boolean expression that you want to write with SQL, you can do as a check constraint. So some of the most simple examples, and these examples are in the book as well. And there's blog posts about these too, if you don't pick up the book, but I'd love it if you picked up the book.
Of course.
Dear listeners and Benedict. But the simple examples would be like, if you have, or one that comes to mind is 2 timestamp fields, where it wouldn't make any sense for one field to be at a time earlier than another field. So you might express that as a check constraint. It's kind of like almost like adding an assertion to your code, or other programming languages. Like, I think Java, what did Java call it? It was like
I think it's
an assert.
Yeah.
It's almost, or it's like it's kind of in Ruby, it might be something that would be like a guard clause or raising an exception or something like that. It's a way you can add additional kind of bug prevention, but it also, again, helps to describe your data model. Like, and the book is based on the book uses a Ruby on Rails app connected to Postgres that's on GitHub. It's a public app, and it's a kind of a learning app. It's called Rideshare, and it's kind of like Uber or Lyft, part of its data model. And you can actually go and check it out right now if you want, if you go to my GitHub profile. But the same app is used throughout the book. And, for example, there's one of the tables and models is called vehicle reservations. And there's a little bit of a twist on the data model, kind of like to mangle it into for examples and exercises purposes. But the idea is you might have like a private company that rents out vehicles. So you might make them available for reservations, kind of like Uber or Lyft, they don't do this. You can't really rent their vehicles, but other rental services like, is Taro one of them or something like that, like a startup? Anyway,
let's assume there is one that does this, right?
Okay, yeah. There's some. I've never used it myself, but there's some other company, at least in the United States, that's popular, that individuals can rent out their cars to other people,
Mhm.
kind of like Airbnb, but for your car.
Yeah.
And so let's say you made a reservation. Well, it wouldn't make any sense to have, your end time of your reservation be before your start time. Or you might want to say that a duration of a reservation is a certain amount of time, like it's at least this much time. Those are things you could do with check constraints. There's another purpose for check constraints, which is how I learned about them first. I didn't really learn about them for data validation or kind of documentation as much. But the other purpose I learned about from Strong Migrations originally, which is a Ruby gem and a tool that can help you write safer migrations. And it encodes a bunch of patterns that help you with at least higher scale databases where you want to change them while other transactions are happening, other queries are happening to the same tables. And one of the things it recommends for is using check constraints because of their additional control, fine-grained control over like when you can enforce them, to use them as a stand-in for, I believe it was for when you want to, like, let's say you wanted to later add a particular field you wanted to add a not null constraint to. I believe this is the example from Strong Migrations. What you can do is you can first add a check constraint, but you can not validate it for all rows. And what that means is that it will only be in effect for new row modifications, but you can basically fake out a not null constraint, and you can say this column value should be not all, but in the check constraint body. And then you don't incur that cost of applying it to all rows. If you have a small size database, like with, I don't know, 100,000 rows or less or something, it's probably not a big deal. You might you might be able to add the not null constraint without this extra overhead of the check constraint as the assister kind of. But if you have a big table with millions of rows and lots of queries, then if you add the not null constraint, if my memory is correct about that, because Postgres is trying to improve these things in version to version, so I believe that this is still an active challenge. It will apply to all of those millions of rows, and in order to do that, it needs to check all those rows, and it's going to lock the table while that's happening. And the length of that lock can cause downtime because queries will time out, that sort of thing. They'll be blocked on that change being applied. So check constraint can be used to help out in that process by first applying the check constraint in a not valid form. And then what you can do is you checked all the rows, you can actually then add the not null constraint and like overlap it. And almost like the check constraint can be used almost like scaffolding in Rails back in the day. I don't know if scaffolding is still a thing. Is scaffolding still a thing?
I don't know. I feel like I haven't seen it around for a long time.
Yeah,
maybe.
Yeah, I haven't either. So for anyone that hasn't used Ruby on Rails in a long time, yeah, scaffolding would help. You could generate a model or a resource, I guess, and you that's been always part of the beauty of Ruby on Rails is you get all this stuff with relatively straightforward generators. You get like a model, and you get a controller, and you get a test, and you get a route, and you used to get like scaffolding stuff, and that would be like some basic views, ERB views, or that kind of thing. So you could start doing CRUD operations with a resource like relatively quickly. But and that helps you, it helps you with, speeding up your development process. You might not stick with the scaffolding, and so check constraints are, it's a little bit of a rough analogy, but there's some similarities where you can use a check constraint, and that's another way to use check constraints. So if you don't use them for kind of your data verification or consistency checking, it might be worth just keeping them in mind for kind of the helper use case.
That makes a lot of sense. Yeah. Interesting. One thought came up while we were talking about constraints in general, and it feels like basically all constraints are like row level, right? They just like look at like and also the check constraint, I guess, just can look at like the row that gets modified, except for the unique constraint that kind of looks at everything else, right? Is it true? Like, is that really the only constraint that we can use to, I don't know, validate the current row against other rows in the database? Or can maybe the check constraint also check like there's no entry with the same date, or well, that would be a unique constraint, but all the other, like the new entry is newer than every other entry in the database or something like that. Is this possible, or is it out of the question for constraints?
Well, you either intentionally or unintentionally set up a perfect segue into exclusion constraints, which which
It
you
was
can
unintentional, but
okay.
good.
So yeah, the another constraint type, and this I think covers all of the available constraint types we I believe have mentioned now, but this is the most or the least commonly used one in my experience, but it's actually one of the, it's really powerful. The syntax is a little wild, but you'll see if you add an exclusion constraint, it'll say, and you describe a table, like in Postgres \d table name, if you're in PSQL, for example, describe a table, and then you scroll all the way to the bottom, you'll see the constraints that are defined at the table level. And with exclusion constraints, you can use them to validate data between multiple rows. And the example that's in the book, and it's a common example, and if I'm being fully transparent, I don't know if I know many other examples, although we did actually use one at where I work recently. And I think the general takeaway, or the high level takeaway, is if you ever are in a situation where, you want to express a scenario that you don't want to happen, that goes beyond one row. Like if you can try to remember that exclusion constraints might be the thing that would help you out, then there's a little bit of a process of, in my opinion, of learning the syntax. It's a little bit terse, like it's not very self-documenting, but what you can do is there's these different operators, and you can say, the example in the book is an easy one to describe, but again, it has the vehicle reservations concept. And the idea would be you don't want overlapping reservations. Like if you and I book the same reservation, that would be bad, because like, do you get the car? Do I get the car? Like, do we neither of us get the car? And right. You might build that as, most Rails developers would likely build that as like an active record, model validation, write specs. Probably still want to do all that stuff, but if it's a very core functionality that's unlikely to change, you might want to consider also augmenting it with an exclusion constraint. And what you can do is you can say, essentially don't allow at insert time, I guess, or any DML operation, insert, update, or delete. You can say, you can essentially have a way to compare that row to any other rows. And you can say, for these sets of values, like this should not be allowed if this were to happen. And it's in that way, it's similar to like a unique constraint where, you'd say, but it's just one column value, or it could be a couple columns, but it's like, you can do the whole row and check that it, there isn't going to be, and so, sorry. And then I wasn't fully explaining it. So with the exclusion constraint for non-overlapping reservations, you can use the time range capabilities, and you can look at the time ranges between two rows, like if you have a start and end time, and you can make sure that there's no overlap within those ranges.
Interesting. Yeah. I think I should look at those and like at least get a little bit familiar with them, because sounds like it might be useful.
Yeah, it's something that probably wouldn't be, it's probably like a occasional capability. And I would say if it probably would make sense as a higher value use case in your application. But if you do anything with time ranges, and you don't want overlaps, it's something to consider. And I believe again, I don't know for sure whether there's similar constraint capabilities in other relational databases, but for sure in Postgres, it's an exclusion constraint. And it's to introduce it, it's kind of like the other constraint types. You'll add it to a table, it'll show up, it'll become part of the definition of your database.
Yeah, makes sense. You just described, or you briefly talked about Rails validations, and how developers usually just start with Rails validations to make sure the bad stuff doesn't happen, then maybe eventually add database constraints. One thing for me, as someone who likes database constraints, one thing that always was a little bit annoying, or still is a little bit annoying, is that to get the user experience right, you still have to write all those validations, and for some cases, even like custom validators and stuff like that.
Mm-hmm.
Do you have any strategies around that? For example, do you know of a way to, I don't know, magically get the validations based on the database constraints? Or do you have a good way of dealing with constraint exceptions, like where something bad happens and then the database or the database client usually throws an exception,
right?
And eventually it just like bubbles up and is a 500 server error, and the user doesn't know what happened. Do you have any strategies or tips on how to deal with that?
Well, I did also cover, I tried to, since the book it's mostly a Postgres book, but it's aimed at Ruby on Rails developers because I'm most familiar with that and wanted to have those examples that were concrete and, based on my real world experience. I have used and have created custom validators like you've mentioned and used all the built-in active record validations. And I try to avoid taking you weren't really asking about an opinion, but it's kind of a hot topic that I'd say amongst, like where to put your kind of validation logic and whether you should put it in two places or one or that kind of thing. And I tried to avoid taking an opinion on that and covering a breadth of application side and database side ways to validate correctness and consistency. But it is like, it's more work. And the naive way, or the most laborious way is to, you're going to do some duplication and some duplicate efforts. I feel like I have seen some generation tools where you could, again, but I don't have any to recommend off the top of my head. I do have a couple tools to recommend though in this area, but just briefly, going back to what we had discussed earlier, if you describe your data model and your relationships, at your table and fields level, it allows another tool to come along and generate code. So it could be that a command line tool could look and inspect your tables and system catalog tables in Postgres, and maybe not, and maybe like interleave the validations in the right spot, or at least list like, hey, you could add these validations. And there certainly are command line tools that do that kind of thing. Mm-hmm. As far as connecting it all the way to the front end, one opinion I read regarding user experience, and now that I said I'm not going to lay down a lot of opinions, let me lay down an opinion. I did see this kind of hot take from somebody that was like, active record validations are not really worth it. And what they advocated for instead was the combination of database constraints, and then also the idea that your application would ever run without JavaScript enabled. Forget about that. Like that was kind of an old school idea too, is like, your application should, but it's like what modern web application runs without JavaScript?
Mm-hmm. Yeah.
So to have the best client side, the best user experience, you want client side validations. So they kind of were advocating for investing in client side validations and database constraints, kind of on the two opposite ends of the spectrum, and that middle layer of model validations to worry less about. It might be similar to, well, anyway, that's kind of one school of thought. because I do think if you add, active record model validations, that's still going to possibly be limited in how much of a user experience improvement you can, or, it might be limited in your user experience depending on how your front end is built.
Yeah.
Maybe I guess my experience in the last few years has been kind of like these separate, SPA front ends or React based front ends, but maybe with Rails and some of the newer front end technologies now, because I'll admit I mostly have drifted more towards back end and even infrastructure, and I'm not as up to speed on Hotwire and Stimulus and some of those things lately. But if theoretically, if they could derive some, if you could do something like add this constraint, but also like propagate an active record model validation and possibly also make that accessible to the front end, that would be great, because you could have, you'd have more bang for your investment of more spots where those validations would show up. A couple tools in the book that I mentioned as well that I'm happy to share here. By the way, there's over 40 gems and Postgres extensions that are mentioned in the book, besides the core Postgres and Ruby on Rails. And I have been tweeting recently as a hook to try to get people to sign up. If you go to pgrailsbook.com, for the next 3 weeks, I'm going to keep sending out 10 at a time from the book, like just basically brief summaries. And, kind of as like a way to entice people to, stay interested in the book, which hopefully is out in the next month or so. But also because, they're all open source tools and I love to help raise awareness about them so that they can, get more use, and the creators and maintainers can get some more attention and help and recognition for their hard work and that kind of thing. So two of those tools are Active Record Doctor. I don't know if you've seen that one. It's a command line tool, and it can do some of the things we've been talking about, like help you identify missing constraints. And it looks at your active record model classes and your database constraints and helps you identify places where you can make those more consistent. So it might be adding either an active record model validation that is consistent with a database constraint you have, or the other way around. And then another one that's similar is called database consistency. The gem is database _ consistency. And that's another command line tool that you can use. And again, it will analyze your both your code and your database and print out some suggestions and recommendations. And these tools can be used by developers individually, and they can also be integrated into like a linting stage or that kind of thing in the development process.
Nice. Yeah, I should check. I've heard about both of them, but I've never used them. But it sounds like a smart idea to just once in a while run them and see what comes up.
Yeah, it's almost like a kind of another helper or an assistant. If you might be on top of things, but I know that one of the ones I put into practice recently was if you have like primary key, foreign key columns that are related to each other, the tool will recommend that they have the same type. It's easy for those types to drift apart, because in newer versions of Rails, for example, I actually just did this yesterday, but I was creating what was I creating? I think I was creating a foreign key constraint, and the default, that doesn't really make sense. Maybe it was a index. In any case, the default integer type, I think it was just creating a new table with a new column that was an integer type with active record, and it chose the Postgres big int type, or but the table being referred to, its primary key was an int, like the int 4 type, 4 bytes integer type. And there's one direction that's fine. You can always put a smaller thing in a bigger container, but you can't go the other way around.
Yeah.
So, and I think being intentional about those types is helpful too. And, it's more of a long-term thing, but, some of the high growth organizations, they do have to convert their, if they didn't use big integers all over, they have to do this int to big int conversion, which is painful. But yeah, anyway, that's just one small example. And it does that by like looking at your types. And like I said, you could also hook it into your development process. So maybe you could get those suggestions as you're doing migrations and that kind of thing.
Right. Yeah, makes sense. Cool. I think we covered all the constraints. We covered how to use them in Active Record or not use them in Active Record. I think we both agree that there's room for improvement there, but still great.
And I think like, sorry to interrupt you. I was going to say that I might have made a couple small mistakes in describing these, and it's because if you don't, they're not the kinds of things you use every day. So I think it's totally normal to, I think what's best for developers is to just kind of at least have familiarity with what they do and how they could use them and keep them in mind. But even myself, like I'm always using the Postgres docs. Lately, I'm also using ChatGPT for generating examples. And that's really helpful especially for things that I kind of know about, but I can go and verify myself. I'm a big fan of anytime you want to experiment with these capabilities, use your local Postgres database, modify your schema, add constraints, run your tests, like find out all of the issues. And using tools like ChatGPT to help you generate examples is another tool to like help with these infrequently but valuable capabilities that the database offers.
Yeah, that's a good idea. Like using ChatGPT just for examples, because for advice, sometimes it gets stuff.
Yeah, advice is sketchier because if you're not familiar with the area, you're probably not in a good position to verify its accuracy. But if you want to generate examples, then you can go and verify like yourself, if it's especially if it's and of course all the regular disclaimers, don't put your company's code in there and that kind of thing. But that's why I think having these kind of like toy applications, toy databases, kind of sandbox things that you can experiment on is very valuable.
Yeah, agreed. Cool. Where can people learn more about the book and about you?
Yes, thank you. Yeah, they can learn more about the book for now at pgrailsbook.com. And that's a landing page where if you give me your email address, I will send you just a couple emails, not many, about updates about the book until it's available, which we're currently, the publisher and myself are currently working towards end of August as the beta release date. And at that point, maybe I'll redirect the URL to the book landing page or something else. But otherwise, I also have run a blog for a really long time, more than 15 years, at andyatkinson.com. And lately I'm doing more blogging, mostly just exclusively about Postgres or Ruby on Rails. And I'm also on Twitter and occasionally on Mastodon and very recently on Blue Sky. Or you can hit me up on LinkedIn or whatever.
What's your handle on those platforms?
I'm using and from Andy or Andrew. So AND and then ATKI, my last name, Atkinson. So it's a little bit, it's not like a word, but and Atke. And I think, I'm using that handle on each of those social media platforms. Okay,
cool. Should be easy enough to find you then. Awesome. Well, thanks a lot for making the time, getting up super early and talking with me about database constraints. I certainly learned a few things here and there. So much appreciated and good luck with the book launch.
Thank you very much for having me and for the opportunity to share with you some of the stuff and about the book. And hope you have a great rest of your week.
Thank you. Everyone else, talk to you soonish. And have a good week. Bye.